Let's now review logic, standard 1. First, Venn diagrams. There's basically 3 different setups for Venn diagrams. You have the circles that intersect, that represents some. You have the circles that don't intersect at all, that represents none. And then you have the circles where one is completely inside another one, which could be all, or it could be some, depending on what's being described. For examples, we could say some cars are black, some red, and some are both. So you have to have a lot of overlapping here. Just the black ones in one bubble, just the cars that are red in the other bubble, and this is the cars that have both black and red in it. An example with none would look like no cars are manual and automatic. Thinking about the transmission, how you drive it. So you have a manual car that can't have any overlap with the automatic car because it can't be both. There can't be anything that has both. You also sometimes have to think of the sense of what the sentence is describing. How can we see this picture, this type of Venn diagram, in an all or some scenario? Take a look at these examples. Here's the same picture. We can describe what we're seeing 2 different ways. You have a big group of animals and a subset or a smaller group, a type of animal, is dogs. So we could say from this picture, all dogs are animals. All is when the small is in the large. All of this group is in the bigger group of animals. All dogs are animals. If we say some animals are dogs, that's because we could have something that's here in the animal group that's not in the dog group, or we could have something here that is a dog, so it's in the dog group, still in the animal group. Let's look at an example shown at the bottom of your page using the Venn diagrams. Now, what you need to remember about the Venn diagrams questions is it's not about necessarily knowing about dogs or cars or triangles. It's about knowing how a Venn diagram is set up, how they look. So, which Venn diagram represents all of the following set of statements? So let's go through each one. Some triangles are acute. So notice the triangle group is the big group. And if you have the large thing that's being described, some of that large thing, some triangles are acute, then that's going to be the triangle group is the big group if it's a sum. So I see triangles, acute, triangles, acute, triangles, acute. So some of the triangles in each of the picture are acute. That works for all of them. Let's look at the next one. Some triangles are obtuse. So in the triangle group, I need to see obtuse. I see it, and I see it in all of them. Some of the triangles are obtuse. Yes. Next. No triangle is both acute and obtuse. So that means we need to have separate bubbles. Acute is here, obtuse is here, because we can't have any overlapping. Well, here's overlapping, so this one's no good. Here's also some overlapping, so this one is no good. Here's acute, here's obtuse. There's no overlapping. Acute and obtuse. There's no overlapping. Let's look at the last one so that we know how to narrow it down between those two. Some acute triangles are equilateral. So if some of the acute triangles, that means acute has to be the big group. So some is when you have the large thing, some of the large thing. So some acute triangles are equilateral because some could be some other type of triangle. So I'm looking for acute with an equilateral inside of it. This one has it, this one's the one. Here, acute and equilateral are separate. We don't want them separate, so it can't be that one. Statements. It's important that we know the statements and how to write their symbolic notation. First of all, the statements can be valid or invalid. Valid means it's logical, written in a logical order. Invalid means not valid. And if you remember that, then you'll remember when we get to the word inverse, it means we use the word not. So you've got your conditional statement. That's usually the original statement. If P, then Q. If there are clouds in the sky, then it will rain, for example. P arrow Q for the symbolic notation. If we want the inverse of that original statement, since in means not, we put the nots in front. Now, we have to think opposite because if there are already nots, we take away the nots. So put in the not or take out the not, but it's all about the not. Converse is flip. Think about what this C looks like. The C is kind of like a little flippy direction. So we take the original statement and we flip it. This is flipped. Originally it was P first, then Q. Now it's Q first, then P. It got flipped. Contrapositive. So much of a word because it does a lot of stuff. Opposite and flip. Opposite meaning put in or take out the not, flip the order. So see how you have not, and then the Q came first, not, and then the P came after. Remember, the squiggly means not. By, conditional, by is a prefix that means to, goes both or two ways, goes forwards and goes backwards. Written as P if and only if Q, goes both ways. Then you have our two symbols for and or. The and symbol is pretty easy because it looks like you're drawing the A. See, it looks like we're drawing the A without crossing it. That's the and. The other one is the or, upside down. The final symbol that you need to know is the three dots. The three dots mean therefore. Usually you see that at the end for a conclusion. So looking at these two laws of logic, detachment and syllogism. Detachment is just when we go in the correct order. If we make a statement that P comes and then Q, if P then Q, and we start with P, that means Q has to follow because that's the order. P then Q. P, therefore Q. Follow the order. Just think of detachment as follow the order. Syllogism, think of this one like linking a chain of events. Link the chain. For example, two statements can be linked. P goes to Q. Notice the next one starts with Q. Q goes to R. Therefore, we go from the beginning, P, all the way to the end, R. P, and then R. C, link the chain. If the Q's match, take out the Q's, go from P to R. P to R. Now, it's important to remember that the contrapositive is true when the conditional is true. They have the same meaning. The converse is true when the inverse is true. So the conditional and the contrapositive basically mean the same thing. The inverse and the converse basically mean the same thing. So we can apply it like this. To the law of detachment, P comes first, then Q. If P, then Q. Well, according to the law of the contrapositive, which means flip this and put nots, writing the contrapositive is also true. So notice how we can start with not Q, therefore not P comes at the end because this and this mean the same thing. This is the same as writing this. Conditional, contrapositive. Using syllogism to write the contrapositive. Well, P goes to Q, Q goes to R. See how they both have Q? So what we could conclude after this is that P has to go to R. That's what we would get from this. P goes to R. But remember, the contrapositive is also true. So I could, instead of writing this, flip it around and put the knots. Squiggly R, then squiggly P, or not R, then not P, which is why this is a valid conclusion. Let's look at a couple of examples. Number 2, consider the following statement. If 4x equals 8, then x equals 2. Which is the inverse of the statement? In means not, like invalid, not valid. I don't switch the order, so the 4x equals 8 has to come first. This one's not 4x equals 8? Not until I get to here. Well, where's the not? That's what this is. That symbol means not equal. So 4x does not equal 8, then x does not equal 2. Number 3, using deductive reasoning, if the first two statements are true, then which third statement is invalid, not valid, or doesn't follow with our laws of logic? Let's start with choice A. If P, then Q. If Q, then V. I see the Q's match. Therefore, it should go P and then V. That's what should come next. Did they do that? Sorta. They used the law of the contrapositive. Therefore, it's valid. This one is valid. We're looking for the one that's invalid, not valid. Let's look at choice B. P goes to Q, Q goes to not V. Okay, those link up. How should it end? P starts, then not V should follow. Well, it looks like we started with V, which means we're using the contrapositive. Flip it around, that means V will go first, but we have to put this at the end and negate it, squiggly P. Do we have a squiggly P here? No, we don't. So this one is invalid. Let's look at the other two choices just to see why they are valid. P goes to Q, Q goes to V. Q's match up, so I should go P and then V. Is that what I end with? Yes, therefore P and then V. So this one, also valid. Last choice, not P, then not Q, not Q, then not V. Not Q's match up, start at the beginning, not P, end at the end, not V. Exactly what I see. Also valid, not the one we want to pick. Good luck on your SOL.